Hello everyone, welcome to Science Center. Today, my group and I will explain how some of the materials in the world are bonded and how they affect the environment in the 21st century. Hope you enjoy. Now, let's talk about potassium iodide, which is an ionic compound. Let's talk about the physical properties of an ionic compound. A large amount of energy is needed to overcome the strong bonds and to change an ionic compound from solid to liquid state, and thus they have a high melting point and high boiling points. Next, let's talk about solubility. Ionic compounds are usually soluble in water because water molecules can separate the positive ions from negative ions and causing them to dissolve. Lastly, let's talk about electrical conductivity. Ionic compounds do not conduct electricity in the solid state because the ions are not free to move about. However, when an ionic compound is melted or dissolved in water to form an aqueous solution, it can conduct electricity because the ions are free to move around in the liquid state. Potassium iodide is largely used in the medical and health industry in the 21st century. Potassium iodide is used along with anti-thyroid medicines to prepare a thyroid gland for surgical removal and to treat certain overreactive thyroid conditions. It works by shrinking the size of thyroid gland and decreasing the amount of thyroid hormones produced. Furthermore, in a radiation emergency, the potassium iodide blocks the thyroid from absorbing radioactive iodine, protecting it from damage and reducing the risk of thyroid cancer. Thus, the main function of potassium iodide is to protect it from the thyroid radiation.
Diamonds are metastable allotrope of carbon. It is famous for its extreme physical quantities. Diamonds are an ideal material for mechanical parts as they resist wear and tear and are very hardy. They can cut with high speed and accuracy. In diamond, each carbon shares electrons with 4 other carbon atoms, forming 4 single covalent bonds. As carbon has 4 valence electrons, and these carbon atoms are in turn covalently bonded to 4 more carbon atoms, it forms a 3-dimensional structure. All atoms are held together by strong covalent bonds, and due to covalent bonding, all the outer electrons of the carbon atoms are used for bonding.
This is a model of lithium fluoride. Lithium fluoride is a white crystalline solid. It is an inorganic ionic compound where lithium cations and fluoride anions are held together by strong ionic bonds in a giant lattice structure, making it hard, brittle, and also have a high melting and boiling point. Solid lithium fluoride cannot conduct electricity, while molten lithium fluoride is a conductor of electricity. Furthermore, lithium fluoride is chemically stable as the valence shells are filled up. Lithium fluoride is used in ultraviolet or UV optics and radiation detectors. It has also made a good impact on the environment as it is used as a flux in ceramic production. This means that it lowers the melting point of silica used in making ceramics. Thus, less energy is needed for the silica to melt, making ceramic production a more energy efficient process. Lithium fluoride is also part of the preferred fluoride salt mixtures used in some nuclear reactors due to its chemical stability. When mixed with beryllium fluoride, the mixture has a lower melting point, thus making it appropriate for use in reactors. The use of lithium fluoride has made it easier for us to have a cleaner source of energy from nuclear power plants.